So in this video we are going to learn about surface area, continuing on with our solid figures. So your only objective is that you can find surface area of all geometric solids. So we're going to go through every single one and kind of show you how to do it with each. Now surface area is the total area of the object faces or the curved surfaces of the solid object. So I like to think of it as wrapping a present. How much wrapping paper would it take for you to put around a box or any other shape? Or if you're painting a wall, like how much paint does it actually need to cover the wall? So this is your steps to how to find surface area. First you're going to draw the net. So up here I have my rectangular prism. So I'm going to draw the net for it. Alright. Then you're going to label your dimensions. So if I had dimensions on here, I'm going to put either using tick marks. I'm going to put the dimensions on here so I know how much it is. So say this is 5, that's 4, and then these would be all different. And maybe this is 3. Alright. Then I'm going to find the area of each section. So I have 6 sections here. So I'd find the area of this one, this one, this one, this one, and this one. And then you're going to add all the areas together because the surface area is the sum of the areas. Sum meaning addition. So let's go through example. We're going to do 2 prisms. So first is a rectangular prism, so the most basic prism we really have. So in a rectangular prism, I'm going to draw the net. That is my first step. Alright, so we have our net drawn. So now we are going to label dimensions. So I know this is 10. I'm going to say that's my longer side. So all these have to be 10. I'm not sure why that showed up. I don't know how to get rid of it. Alright, so we're going to continue labeling. We're marking this. So these lengths right here, we're going to say these are our 6s. And then notice what other lengths would be 6. This side right here would fold up to hit the top right there, so that is also 6. And then the remaining lengths would fold up, and those would be 4. So now I can find the surface area, or the area of each part. So here I have 6 times 4, which is 24. This is also 6 times 4, which is 24. This is 10 times 6, so this is 60, along with this one. This is 10 times 4, base times height, which is 40. So then, to get my surface area, which we usually generally label as SA, we add up all our different areas together. So I have 2 24s, so I'm going to go 24 times 2, plus 60 times 2, plus 40 times 2. Alright. So adding them all together, I get 248, and then my units would be squared meters. Alright, so the next prism that we're going to do is a pentagonal prism, so something that's a little more difficult. I have 4 rectangular faces, so I'm going to make a big line of rectangles. And then we have the pentagon above and a pentagon below. And these are a regular pentagon. Alright, so then on my rectangular faces, these are all 10. And then my pentagon, since it's regular, has all equal sides, and those are 8.05. And I can mark all these as such. Alright, so it's easily, I can find the area of these right here. I go 8.05 times 10, which is 80.5. Alright. However, to get the area of my regular pentagon, we're going to have to go back to when we did that. So I'm going to draw my pentagon off to the side. Right there. Now we know this is 80.05, and then I give you the radius, which is 7 and 7. So then I need to find my apothem, because remember it's 1/2 AP. We know our perimeter to go 80.05 times 5. So then I need to take it times my apothem. My apothem is located right here. So I have this right triangle I need to solve. We know this is 7. We know this is 4.025. So I can use Pythagorean theorem, or you could figure out the angles and use trig to figure out this side. So I have 7 squared equals 4.025 squared plus, let's say, a squared. And then just doing our calculations, we've done this enough that I'm not going to go through everything with you. But you should get your apothem to be 5.7. Alright, so now I can find the area of this by going 1/2 my apothem, which is 5.7, times my perimeter, which is 8.05, times 5. And I get that to be 114.7. Alright, and then this is also 114.7. So now I can add them up. So I have 114.7 times 2 plus 80.5 times 5 of them. And it gives me a grand total of 631.9 feet squared. Now you could be a little off just or square feet. Now you could be a little off just based off of where you rounded. It's kind of like a rounding error, but you should be somewhere in this area, somewhere in the 630s or 620s. Alright. So now we have a cylinder. So the cylinder net looks like this. So we have a circle. We have 2 circles, and to get the area of a circle is pi r squared, which we did before, so that should be easy to find because you have your radius right here. But now here, this side length here, that is your height, which how far apart are your 2 circles. To get the length here, that wraps all the way around the circle. And what it's called when it wraps all the way around the circle, that is your circumference, which remember is d pi, or 2 pi r. So doing my example down below, I have a radius of 6. These are 4.9 centimeters apart. They're the same. And then to get this is 12 pi, because my diameter is 6, or my diameter is 12 because my radius is 6. Alright, so to find the area, this is 36 pi, 6 squared. So this is also 36 pi. But just plugging into our pi r squared, 6 squared is 36. And then 4.9 times 12, this is 58.8 pi. So adding it up, I have 36 pi, and I have 2 of them, plus 58.8 pi, $72. And you should be checking with your calculator right now in this little downtime to make sure you get the same answer me. But I get the surface area to be 410.9 squared centimeters. Alright, so now we move on to pyramids. So a pyramid here is what the net should look like. In pyramids and also in cones, this is going to go. You have a height and you have a slant height. The slant height is actually on the side. So when you draw the net, you have triangles on pyramids, and that is your slant height. And we label slant height with the letter L. You do not actually see the height because the height's in the middle of the triangle. Then when you unfold it, we're going to use the height for volume, but not for surface area. Alright, so taking a look at what I have here. Move it over so we have more room. I need to find the surface area of this, so I'm going to draw on my net. I know this is 10. And all I need is the height of all of these triangles, which again is my slant height, but I don't give it to you, so we're going to have to figure it out. Notice in here you have a right triangle, and you know two sides of the right triangle. You know this is 12. Now a lot of students are tempted to say this side is 10, but it's only halfway across, so that is 5. So I can go 5 squared plus 12 squared using our good old Pythagorean theorem equals c squared, and it comes out that this side is 13, so my height is 13. So now I can find the area of each part. 10 times 10 is 100. Here we do 1/2 base times height, which is 10 times 13. 10 times 13 is 65. Alright, so all these have areas of 65. So I can go 65 times 4, because I have 4 of them, plus 100. Plus 100 gives me 360, and my units are squared feet, because it's area. Two more examples, because we have 2 more solids to go through. We have a cone. Now, cone, just like before, we have our height, which we're not going to use, because that is used for volume. But we do have our slant height, in which we're going to use, and again we label that with L. So here is the net, and you notice here, this length here, and this length here is your slant height. Now to get the area of the circle, that is pi r squared. That is nothing different. However, to get to the area of this is a new formula because it's not in the shape you've done. The formula for that is pi r L. Alright, so pi times the radius times the slant height. Alright, so to find the surface area of our cone, like so. Alright. So we have our radius, which we know is 10, and we need to know our slant height. This height does not do us any good, except to help us find the slant height. So again, just like the previous example, we're going to do Pythagorean theorem. Equals L squared. And it comes out L to be 26. So this is 26, and this is 26. Alright, so now to find the area of that, for each part, we're going to go 10 squared pi r squared, that's 100 pi. This one we're going to go pi rl, so pi times your radius, which is 10, times your slant height, which is 26, which is 260 pi. I'm just going to add those two together to get 1030, and it's 0.97, or if you round to 1, it would be 1031 squared centimeters. Alright, last example is a sphere, and this is going to be another new formula that you haven't learned, but that's only 2 formulas. Everything else is all your other area formulas. So here's a sphere, and all we're going to use in the sphere is a radius. And again, we don't really draw a net for a sphere. So we have 4 pi r squared is how we're going to find the surface area of a sphere. So notice it's pi r squared, but then there's a take times 4. So it's not really much different than what you're used to. Pi r squared times 4. So here we just need our radius, which our diameter is 14, so our radius is 7. So we're going to go 4 times pi times 7 squared. 49 times 4, because 7 squared is 49. It's 196, and we're going to take that times pi. 96 pi. It comes out to be 615.8 squared meters. Alright, so review to find surface area. I highly recommend you draw the net, and you want to be very accurate and neat. Otherwise you're going to run into issues. To find the area, and then you find the area of each section, and then you just add all the areas up. I know it's kind of tedious, but you need to take your time and slow down, and then you're less likely to make a mistake. I know when I go fast, I make mistakes in surface area a lot. So again, the new formulas for like the body of a cone, it's pi times radius times slant height, and the formula for surface area for a sphere is 4 and then just pi r squared. That is it for this video on how to find surface area.